Hi everyone, another video in this playlist looking at proportionality. The first couple of videos looked at the concept of direct proportion, and we came up with the rule that when we're talking about direct proportion, we've got a variable, let's call this one x, and it's equal to the constant multiplied by the other variable, let's call this one y. So when we're talking about direct proportion, and let's just remind ourselves, direct proportion means they operate in the same direction as each other. So for example, when one variable increases, so does the other. We're talking about a constant multiplied by the other variable. We're now moving on to inverse proportion, and just like you've probably done throughout your GCSE mathematics lessons, you'll have understood the concept of inverse, meaning the opposite operation. So let's have a look at establishing a rule for inverse proportionality. Now, inverse proportionality, if you think about it being the opposite to direct proportionality, if direct proportionality means the two variables travel in the same direction together, i.e. when one increases so does the other, then inverse proportionality would mean the exact opposite, i.e. when one variable increases, the other one decreases. In terms of establishing a formula, well, let's have a look at what the inverse of the direct proportion formula would be. So if the direct proportion formula was one variable, which we call x, was the constant times by the other variable, then inverse proportion is going to be the constant inverse of times divided by the other variable. And that establishes our inverse proportionality formula. The idea that as one variable goes up, the other one comes down. So if direct proportion is constant times variable, then inverse proportion is going to be constant divide by variable. So let's have a look at this first question then and see if we can apply this rule. P, so that's our first variable, is inversely proportional. So that becomes k divided by instead of k multiplied by. So it's inversely proportional to q. So I've established my rule, and then just like we did with direct proportion, the first part of the question is going to be to try and find this constant value. So it says when p is 2, so I can substitute 2 in there, then q is also going to be 2. So I can substitute a 2 in here. So what I now need to do is I need to work this through and think about what the constant value is going to be. This time, what's stopping the constant being on its own is this divide by 2. To get rid of divide by 2, I'm going to have to multiply by 2, and we do the same thing to both sides of the equation, otherwise it's no longer balanced. So on the left-hand side, I'm left with 4. And on the right hand side, the divide by 2 and the multiply by 2 cancel each other out, so I'm left with k. So my constant is 4 in this inverse proportionality question. So we now rewrite the rule. We still have our first variable p. Our constant is now worth 4, so this part of the formula can become 4, and our other variable here is q. It then says find p, so I don't know what p is yet, so I'm going to leave that as p. My constant is 4 when q is 8. Okay, and that one's really simple. It's already told us the value of p. P is 4 over 8, or if I wanted to cancel that down, 1/2. So there's my final answer. P is equal to 1/2. Let's just do a bit of common sense checking here and check that the proportionality is working in the same direction, or the correct direction, sorry. When p was 2, q was 2. When q went up to 8, so as q went up, so if we think about this in terms of proportionality, as q has increased from 2 to 8, let's look at what's happened to the other variable p. Well, p's gone from 2 and it's gone down to 1/2. So our inverse proportionality holds true. As one of the variables has increased, the other one has decreased, so it's probably the correct answer that p is equal to 1/2. Let's turn our sheet over and let's try practicing another inverse proportion question just to make sure we're happy with these. R is inversely proportional, so R is an inversely proportional means constant divided by. R is inversely proportional to the square root of S. So this one on the face of it looks quite complicated, but we just need to kind of follow the same steps. It then says when R is worth 1, so I can substitute a 1 in here. My constant, I don't yet know, is equal to S is 36, so the square root of 36. So let's see what we can do here. We can't do anything with the 1 yet. Constant we don't yet know. I do know the square root of 36 is 6. So I've now got 1 is equal to my constant divided by 6. Balancing then, I want to get rid of the divide by 6, so I need to times by 6. And I do that on both sides. So I end up with 1 times 6, which is 6. And that's equal to my divide by 6 and my times by 6 cancel each other out. So my constant in this example is 6. So back up to the rule, rewrite it, first variable equals constant is now 6 divided by second variable because it's inverse proportion. Find R, so I don't know what R is, when S is 9, so 9 goes into the place of where S is, so it's a substitution in there. Let's see if we can solve this now. So 6 divided by square root of 9 is 3. 6 divided by 3 is 2. So R is worth 2. Let's double check that they're inversely proportional. So S went down from 36 to 9. So we're looking for R to go up. R went from 1 to 2. So R has increased as S has decreased. So they are indeed inversely proportional. Another one here just to keep these practicing. If you do want to practice these, obviously just stop the video and have a go at it. We've got T is inversely proportional to the square of U, so U squared. Okay, when T is 0.5, don't know my constant yet, U is 2, so 2 squared. So I end up with 0.5 is equal to my constant over 2 squared, which is 4. I want to find my constant, and my constant is currently being divided by 4, so I need to times by 4, and I've got to do that on both sides. So 0.5 multiplied by 4 is 2, and divide by 4 and times by 4 cancel each other out, leaving me with just k, so my constant is equal to 2. So as per the last couple of questions, rewrite the formula. There's my first variable, my constant is now 2, and there's my second variable, U squared. Okay, find U, so this looks like it's going to be quite a tricky one actually, because we're trying to find the one that's embedded in the equation. Find U when T is 0.125, so it's an eighth. Okay, so we end up with this. Now, this is going to require a little bit of rearranging here. We want to find U squared, and U squared is currently down here. We're dividing by U squared, so we need to get that up so it's on a level. So we're going to times by U squared to move that, and we're going to do that on both sides. So we now end up with 0.125 multiplied by U squared equals, and on the right hand side we're nice and tidy now because the divide by U squared and the times by U squared cancel each other out, so I'm just left with my constant value of 2. Let's move this up here. Apologise if this is looking a little bit messy at this stage. We've now got 0.125 times U squared, so let's write that one out again. 0.125 times U squared is equal to 2. I want to get U squared on its own, or ideally I want to get U on its own in a minute, so U squared to begin with, to get that on its own, it's currently being timesed by 0.125. So to get rid of times by 0.125, I'm going to divide by 0.125, and I've got to do that on both sides, otherwise it's not going to be balanced. So on my left, times by 0.125 and divide by 0.125 cancel each other out, so I'm left with U squared. 2 divided by 0.125, that's quite a difficult concept to get your head around. So it's asking us how many 0.125s fit inside 2 whole ones. Well, let's think about how many of these fit inside 1 whole one. This is an eighth. This is the fractional equivalent of an eighth. So that means 8 of them fit inside a whole one. Therefore, inside 2 whole ones, there's going to be 2 lots of 8. So there's going to be 16. I've got U squared now, but I only want U, so I need to get rid of the squared. Inverse operation to squared is square root. So I'm going to square root on both sides, and that will leave me with, on the left hand side, U, because the squared and the square root cancel each other out, and on the right hand side it will leave me with the square root of 16, which is 4. Double check. T went down from a half to 0.125, so hopefully U's gone up from 2 to 4. Yes, it has. So it's travelled in the right direction, so it looks like that's right. Okay. Final inverse proportion question then, and then I'll leave you to have a go at this past paper question on the bottom here. V is inversely proportional to the cube of W, so W cubed. Okay, when V is 5, W is 1. So I've got 5 equals K over 1 cubed. 1 times 1 times 1 is 1. I need to get rid of this divide by 1, so I'm going to do the inverse, which is times by 1. Got to do it to both sides, remember. So I end up with 5 times 1 is 5. My constant and my divide by 1 times by 1 cancel each other out, so my constant is 5. So let's substitute that in. V is equal to my constant, which is now 5 over w cubed. Find v, so I don't know what that is, when w is 2. Okay, really simple this one then. So 5 over 2 cubed, 2 times 2 times 2, 8, and there's no reason why we can't leave that in fractional form, so v is equal to 5/8.